Welcome to Burlap Teachers. Enjoy the video.
You start by assembling hardware and software quickly. Begin with a Raspberry Pi or ESP32 plus a USB or i2's microphone array and a speaker. Pick components that match 3V or 5V logic. Install Python 3. 8. Create a virtualenv, then pip install speech libraries. Once done, configure serial or I2C pins and test power delivery, because stable power avoids erratic behavior. Make sure to reserve one USB port for debugging. That prevents interrupting your audio I/O later. Next, you implement the core voice stack and pipeline. Install a wake word engine, Porcupine, or a lightweight custom model, so the robot listens only when needed. Then add streaming ASR like Whisper or Vosk and connect outputs to an intent parser such as Rasa or Dialogflow. This translates speech into structured commands. Route audio through ALSA or Pulse Audio with small buffers to reduce latency, and test full loop recognition so you can see how wake word, ASR, and intent parsing interact in real time. Finally, you wire the intent outputs into safe control logic. Map intents to motor and actuator commands, include safety limits and confirmation prompts for risky moves. This prevents unintended motion. Implement a state machine and retry rules so commands are deterministic, and add logging of audio and events for debugging. Once done, test edge cases and enable OTA updates so you can iterate on models. If something fails, first check microphone gain and wake word sensitivity. Most issues are bad input or mistuned thresholds.
Thanks for watching. Consider subscribing if this video helped you.